So we're going to title this topic, our favorite word, the big word that some of you were making fun of pronouncing, right? Our topic is stoichiometry. Stoichiometry. Okay, this is learning target 1101. And what we're going to do is talk about the steps to solving these types of problems. I'm going to make it down here. Stoichiometry problems. Okay, and so the first thing that I'm going to give you is sort of the general equation. Okay, the general equation. It's going to be a word equation that is going to always apply. Okay, here's our general equation. We're always going to start with the quantity given in the problem. I've said that before, right? That you always write the number that they give you in front. Quantity given. Then we also always end up with, this is going to be quantity asked for. Okay, that is quantity asked for. This is going to be mass to mass, okay? This first conversion is always converting using the molar mass of the given chemical. And what's on top is always 1 mole of the given. Right? Remember, if the formulas are the same, the number in front of mole is always 1. Okay. Then we have to find the mole ratio of the given. And also the mole ratio of the asked for. The second conversion, this guy here, I'm circling in pink because this is from the balanced equation. Okay, that's always from the balanced equation. Then the third conversion uses the molar mass of what's asked for over 1 mole of that same chemical. Okay. If you were to follow this every single time, you will get the correct answer every single time. Well, okay. You'll have the correct setup for the problem. You will actually have to do the math, right? And sometimes the math kind of gets confusing to us. We're going to go through this now step by step with an actual example. Okay? So step 1. The first thing you always have to do is balance the equation. Okay. Step one is balance the equation. So I'm going to write an equation for us. C3H8 plus O2 makes CO2 plus H2O. Anybody know what type of reaction this is? Yes, it must be combustion, right? Hydrocarbon, right? Hydrogen and carbon together in a compound with oxygen always, always, always forms carbon dioxide and water. When you're predicting products, these two are always your products for combustion. Okay. Now we have to balance. I'm going to use pink, right, because I used pink in my general equation. 3 carbons here, so I put a 3 out front of carbon dioxide. 8 hydrogens here. So in order to make 8 hydrogens on my product side, I have to multiply by 4. Then when I count up oxygens, 3 times 2 is 6, plus 4 times 1 is 10. So in order to get 10 on the reactant side, I put a 5 as its coefficient. What number is out here even though it's not here? 1. A 1. Remember, if there's no number, it's a 1. Very good. Step 2. Circle what's given and underline what's asked for. Okay. I need to give you a problem in order to circle and underline. So here's our problem. If 5.0 grams of water are produced from the reaction, how many grams of CO2 are produced? Circle what's given, underline what's asked for. Remember, make sure you circle the number, the unit, and the chemical formula. Then for what is being asked for, make sure you underline the unit and the formula. This is grams to grams of 2 different chemicals. So far, so good. Step 3. Write what's given on the left and draw in the conversion factors. Remember, people call it dimensional analysis. I've called it times goes into, right? We're going to write what's given, 5.0 grams of H2O. Since I know it's a grams to grams, I know I need to draw 3 conversion factors to get to my end goal. Okay. Now we're going to tackle each conversion factor, right, and what goes in each one. Step 4, find the molar mass of the given and write it on the bottom of the first conversion. One mole of the given goes on top of this conversion. Okay. I'm going to write it out again so that we can kind of see the progress that we're making. Grams of H2O, right? So, I know 1 mole. My given chemical is H2O, so I'm going to write H2O here. I now need the molar mass, right, to put on the bottom. So I'm going to solve it down here. H is 1.0079 grams times 2. Oxygen is 15.999 grams. When I add these up, I get 18.0148 grams. This number here, 18.0148 grams, goes here. H2O. Remember, when these have the same formula, the number 1 always goes with the mole. Okay. When those have the same formula, the number 1 always goes with the mole.